Good afternoon, everyone. Welcome to Concordia University's fourth space. Thank you for joining us for today's event, LEAD's Mini-Symposium. And we know that's leadership in environmental and digital innovation for sustainability. But to help situate you, we are streaming to YouTube. We're live from fourth space, and we are located here on unceded Indigenous lands in Chibuike, Montreal. And here at fourth space, we work with our university community, help mobilizing knowledge, co-creating daily activities, looking at projects, things in development across the university. We're running today's event as a live stream Zoom meeting also. So anyone joining us there, I'm not sure if we'll have time for questions, but if you have comments, definitely add those into the chat. We'll get those to the right people at the end. Those of you here in the space, you'll be passing microphones around, but that's so that we can all hear online as well. Okay. With that, it's very much my pleasure to hand things over to the program coordinator for the Answer Create Leads project, Odile Gerwing. Odile, welcome.
Thanks everyone, and thanks for Space for welcoming us again in this beautiful space. Welcome everyone to the 2024 Symposium of the Leadership in Environmental and Digital Innovation for Sustainability program, le programme de leadership en innovation environnementale, numérique et durable. The Mini-Symposium is an annual event that we usually organize at the beginning of the fall semester, and it's meant to foster some connection amongst the LEADS community. I see that there's many new and returning trainees. Thanks everyone for joining us today. It's much appreciated. After the welcoming remarks, we will welcome our returning trainees to the stage for 3 rounds of panel discussions. In total, 13 of our returning trainees will be doing a 3-minute speech about their respective research, and we will then, after each panel, open the floor for some quick questions and potential follow-up questions. But after the panels, there's going to be a second part to this workshop, which is a case scenario workshop. So please stick with us for the second part of the mini-symposium, because this is going to be the opportunity for you to use some soft skills, to think of an exercise and to work with each other around some very fun activities. So finally, after all of this, we will conclude the event with some networking and some snacks and refreshment. And I will now pass the word to the program director, Professor Damon Matthews, who's sitting behind.
Okay, so this is the order of events. I think we should, it says it goes till 5. I think that's not quite real. We should be finished up sometime before then. But basically the first half of today's event is going to be presentations followed by questions. We're going to have 3 rounds of 4 or 5 presentations, and so we'll try to go through that in about an hour and a half. And then I'll turn it over to Odile to introduce the next, the second part of the day. So welcome, thanks everyone for coming. Yeah, my name's Damon Matthews. I think everyone knows about the LEADS program. I didn't plan a big introduction because we also had our Sip and Connect, I guess it was, about a month ago that many of you were at. So just very quickly, the LEADS program is a graduate training program meant to foster connections between the world of AI and digital innovation and sustainability science, and to help people understand how the pace of technological and digital change could be leveraged to contribute either to your own research or towards solving the world's sustainability goals. So that's the LEADS program in a nutshell. This is, after the Sip and Connect event that we had, this is the second event of the year. So just quickly to go through what to expect for the rest of the year. For any of you who don't already know and haven't signed up yet, there's an event coming up on Thursday this week, and there's still space to come and register. It will be in French, so it's a good opportunity for you to practice your French if it's not, or if you would like to practice it, or listen to an event in French if you are amenable to that. But please come to this. It'll be a great panel with lots of interesting people speaking about an annual report that Future Earth puts out every year called the 10 New Insights in Climate Science. So this is the kind of French translation and French launch of this year's report. It's kind of like a mini IPCC report, just based on kind of new research insights that have come out over the last year. So please come to that if you like. It's hosted at HSA, and like I said, there's still space to register and attend. In the new year, the main event to plan for is our 2-day annual leadership training event, which is a mandatory event for anyone who hasn't done it before, and a welcome to come back and participate again if you have. So that will be on this year on February 26th and 27th. For those of you who have Concordia's calendar memorized, you will note that this is Reading Week, and I apologize for that, although it was we had a lot of trouble finding dates for the venue, and this was the one that was open. So it's a Wednesday and a Thursday during Reading Week. So at the very least, you'll have no class conflicts. So that will be one advantage of that scenario. So yes. So again, everyone is welcome to attend. If you haven't already come, the expectation is you will attend one of these events or more during your time as a lead student. A little bit later on in April, we have a joint event with the Applied AI Institute. So there'll be more details. This is obviously quite far in the future, but expect in the new year an announcement about that event. It would be an opportunity to come and do a digital poster in this space in collaboration with students from the Applied AI Institute. We did this, some of you participated in last year's event on the same topic, and it was quite a successful event, so we thought we would try again. And then finally, the summer school, which is the other big mandatory event for anyone who is new to the program and hasn't already done it. The dates are to be determined, but it'll be right at the beginning of the summer semester. It's usually somewhere in the vicinity of the first 2 weeks of May. Last year, I think we started on May 7th. It might be somewhere around then this year. So again, if you're a Concordia student, you can just register for this. It's a regular graduate course. It's a 10-day intensive graduate course, so it's it's a bit of a wild ride, but we do lots of interesting things. We have lots of guest speakers, learn a little bit about a bunch of different topics. So many people in the room were at the course last year, so feel free to chat with them about their experience. But look out for that, and especially if you are from a different university, you need to start the process of registering for this course a little bit earlier. If you need to have it approved as an elective in your program, let me know. We can do that. It is a graduate course, and most students in the past have been able to have it be an approved elective, and then you register through the inter-university portal and join the class. So that's the quick introduction. So I think we'll move right on to the panels. We're going to try to go through each panel in about 25-30 minutes. Each speaker will have 3 minutes to do their presentation, talk a little bit about their research, and then we'll have an open question session for 5 to 10 minutes that you can ask questions of any particular panelist. Are we ready to go? Okay, so first up, so maybe I'm going to return to my seat now, and then I'll introduce the panel. Okay, this microphone works great. So I'll quickly introduce our first panel. First up, we have Mikaela Gerwing, who is in her 3rd year of the program, I believe, something like that. She's a PhD student here at Concordia. Next, Jennifer Donnini in year 2, a master's student at Concordia. Alex Pache in year 4, maybe 5. 4.5. Okay. Alex is also a PhD student at Concordia, and then Olivier Chalifour, also in year 2 of his PhD program here at Concordia. So without further ado, Mikaela, and I will start waving at you after 3 minutes if you start to go over time.
Hello. Okay, great. I do have a slide. I don't know. Oh. Hi, everybody. My name is Mikaela. As Damon said, I'm a PhD student here at Concordia. I'm in geography, and I work under the supervision of the wonderful Dr. Sarah Turner, and also co-supervision of Dr. Renata Ferreira in Brazil. So my PhD research is kind of broken down into 3 themes per se. The first is the rehabilitation and reintroduction of bearded capuchin monkeys in northeastern Brazil, looking specifically at behavior and personality. The second is human-wildlife coexistence in the area of release for the first theme. And the third will be looking at the effectiveness and ethical integrity of Latin American wildlife rescue centers in 3 realms: animal welfare, human welfare, and conservation. So the pictures that you see here are from a 5-month field season in northeastern Brazil, which was focused on the first 2 themes of my research. So during those 5 months, I was able to work with a group of capuchin monkeys from rehabilitation all the way to reintroduction. That involved, during the rehabilitation phase, going in and doing behavioral observations of these monkeys on a daily basis, and also partaking in rehabilitation training activities to prepare them to be released back into the wild. This also involved finding a reintroduction site and preparing for the reintroduction, building a soft release enclosures for the monkeys, and monitoring wild monkeys in the area of the release. I also spent time working with the community in the area of release, doing interviews and presentations. I monitored wild monkeys, and I got to work with 3 levels of government and a nonprofit and a lot of local collaborators. Finally, I got to do some reintroduction monitoring in the area of release, working with new technologies to track monkeys from a distance. So I've been part of LEADS now for 3 years, and I've benefited from various aspects. I've gotten to take Damon's class. I've done the training workshop, the leadership training workshop. I've participated in various workshops and presentations, and I also got funding for some of my research in Brazil from LEADS, which was incredibly helpful. And I also recently found out I will be doing an internship, which is part of the LEADS program. We have to do a 200-hour internship, and I'm going to be doing that with a nonprofit organization called Planet Madagascar, working on their online spaces for fundraising. And I don't know if I'm at 3 minutes, but that's kind of what I have.
That's a good place to stop. Great. Let's move on to Jennifer.
Okay. I also have a slide. I don't know if it's okay. So hi everyone, my name is Jennifer. I just want to say thank you to LEADS and Future Earth for supporting my research. So my research focuses on the link between spectral diversity and tree biodiversity. So nearly 30% of tree species worldwide are threatened with extinction, and this poses a risk to biodiversity and the ecosystem services that forests provide. And to combat this, we need tools that can monitor large areas quickly and effectively. So my research uses Sentinel-2 satellite data, environmental data, and forest inventory plots to test the spectral variation hypothesis in Quebec's deciduous, mixed, and boreal forest. And this hypothesis was proposed over 20 years ago, and it suggests that spectral diversity in satellite images reflects environmental heterogeneity, which in turn is linked to species diversity. So in my research, I explored how well spectral diversity could predict 4 aspects of biodiversity: species richness, Shannon diversity, functional diversity, and relative abundance, which is percent conifer in this case. And a key part of this research was examining spectral signatures. And spectral signatures represent the amount of light reflected from an object across the electromagnetic spectrum. And what I found was that the spectral relationship to biodiversity is weaker than suggested by this spectral variation hypothesis. High and low levels of biodiversity show overlapping spectral signatures, which makes it hard to differentiate them with remote sensing. So spectral diversity proved to be a more effective as an estimate of the percentage of coniferous trees in a forest inventory plot than any of the other biodiversity indices. And this is because of the leaf shape. So broadleaf trees reflect a lot of light, and coniferous trees absorb more light. So you can see the difference in the signature, and this makes it so that we can estimate the proportion pretty accurately. So instead of capturing the number of different species, spectral diversity ends up being much better at picking up changes in canopy leaf structure. And this finding is important because it helps explain why the relationship between species diversity and spectral diversity is relatively weak in Quebec's forest and in other regions where this hypothesis has been tested. And it highlights the need for researchers to rethink how they use remote sensing data in this context. You could build countless models, throw in thousands of predictor variables, use AI, use machine learning, but if the fundamental spectral signature doesn't capture meaningful differences, none of it will give you reliable results. Thank you.
That was excellent timing. Thank you. Alex, go ahead.
Hi, everybody. I study environmental change using tree rings. So we all know the environment is changing. It's changing in a really rapid rate. And it's quite possibly changing much faster than it has in a very, very long time. One of the ways we know this is thanks to environmental proxies. Environmental proxies are natural archives of past conditions. They come in a variety of forms. So we could have ice cores, there are sediment cores, coral reefs, but I specifically, of course, study tree rings. And so trees put on a ring of growth every year, and that ring can capture the local conditions if they are in a sensitive location. So, excuse me, what we do is sample hundreds of trees from a specific location and try to understand these patterns and how they relate to the local environment. So you could have simply scars that are related to fires, so you could see how the fire extended through an ecosystem and what years that happened. Or you could go and look at the ring widths themselves. So a simple example is with precipitation. So in some locations that we study, when the rings are thick, there was a lot of precipitation that year, and when they're thin, it was a drought year. And so we could study that pattern and then model it for the years that we have both the weather data and the tree rings, and then we use that model on the rest of the tree rings for before we had data. And that gives us a understanding and a context of the changes we're seeing today by extending our weather data or precipitation data, among other things. And so specifically for where I'm studying is in South Central Quebec, and I'm using old growth trees because, of course, the longer you have of tree rings, the more you could go in the past. So I have two different data sets. I have alpine tree ring data sets. So we go to some of the highest mountains in Quebec that are accessible, and we sample the trees along the tree line where the trees start to get stunted and they stop growing and it becomes tundra. And that's actually a pretty rare ecosystem in Eastern North America. And there is, it's a research priority in general because there is a concern that these ecosystems will be one of the first significantly affected by climate change in Eastern North America. And the goal there is to understand how temperature has changed in the past few hundred years, because we only have temperature data in those regions for around 50 years, and we should be able to extend them about 200 years into the past using the old growth trees that are at tree line. And then my second data sets are from cedar forest in the Rimouski area and Gaspésie area, and cedars are the oldest living tree in Eastern North America, so that allows us to go really far back in time, and we actually go even farther back in time by diving into the lakes and pulling out the trees that have fallen into the lake and have been preserved underwater where anoxic conditions really reduce the rate of decomposition. So we're able to go around 800 years into the past in those locations. And the hope here is to really fill in some gaps of our past environmental conditions and give us information to better understand those sensitive ecosystems and make us able to better manage them sustainably in the future. And as for leads, I, of course, have attended all the courses, and I had an internship with Reimagine AI, training a climate chatbot. And it's also encouraged me to look into how to apply AI and machine learning to our modeling for our tree ring reconstructions.
Great, thank you, Alex. Olivier.
Yeah, so hi everyone. basically, my project revolves around natural-based climate solution, wildfire, and AI. And the goal is actually to predict the impact of future wildfire on global reforestation project using AI. So we know that, like for couples of years, wildfire trends, especially in northern latitude, are going up. We have more wildfire, etc. We can think of last year wildfire season in Quebec, where Montreal, New York, and Toronto were like quoted in a thick smog due to the wildfire happening in Quebec, which was dangerous for health. And those wildfire trends also can happen, or like the power of our reforestation project that we apply across the globe. So reforestation projects are not perfect. There's always two sides to the coin. So reforestation project here is, yes, there's like CO2 capture from them, but there's also an increase in connectivity. So if you have two forest patch that are separated by fields in the middle and you do reforestation there, when a drought happens in the future, well, it's more likely that the fire will spread from the first patch to the second one due to the reforestation project. So that can be dangerous, and we need to do good management of those reforestation projects so that it not happen. There's also an increase in precipitation from reforestation project, and the albedo effect, which is at northern latitude, reforestation project can actually increase the temperature, and it's actually echoes what Jennifer said, because needle leaf in the end absorb more energy. In that case, we can like eat up locally the environment. So like both effect of what the wildfire trends that is increasing and reforestation project, the combined effect is not known, and is like what I'm trying to assess using a global climate model, the UVK-SCM, which has a fire representation in it, but is fairly limited because of the model itself. So I'm trying to go around that and improve the representation inside the model using AI. In my case, I'll be exploring different one. Right now, I'm doing my comprehensive exam, so I will be like exploring the AI scheme in the future. But the goal is to combine the two and actually look at the implication of reforestation inside the model. So if we do global reforestation, what is going to happen with the wildfire trends in different scenarios of climate change. So I'll be looking into that in the future. And well, for my experience with the lead, well, it was pretty great, actually. I really loved the program personally. With the class last year was nice. And I highly recommend the leadership workshop in February. It's really nice. So yeah, thank you.
All right, thank you, everyone. So we have a round of applause. So yes, there's a microphone, a roving microphone. So if you'd like to ask a question either to someone in particular about their research or to the panel as a whole, please put up your hand and we'll jump in.
Okay. So it's from Mikaela. Which factors did you select your reintroduction sites? Please.
Okay, so there was a lot that went into it. So the general area was already predetermined by the federal government, provincial government, local government. There was a lot of different entities involved, as well as a private landowner that I was working with. But in terms of a specific site, there are various factors that go into it. But with a reintroduction, you want it to be far enough away from human settlements so that monkeys aren't encouraged to go where the people are, but also close enough that you can access it as a researcher. You want to release somewhere that has food and water that are natural to the monkeys, and you want it to be in a place where the monkeys are like that species is either like native to that area, and there's like others of the species there now, or where they've been extirpated from, so they used to live there and then they were they went into local extinction. But you need to make sure it's also safe from things like poaching and like all different human factors. You don't want people going in and messing with the monkeys that you're reintroducing. So it's a very tricky balance, and there's a lot of different people involved. But in this case, we were very lucky to work with government agencies and then a nonprofit landowner who had a ton of land where we actually were able to release the monkeys on private land. So they were more protected from outside influences because they were on private land, but it's still something you have to consider.
Thank you.
Other questions?
Thanks. I have one for Jennifer. I'm curious to know, so in your, I guess there's enough variation between the coniferous trees and the broadleaf to be able to detect differences in the absorbance. Is there any other case where there would be enough variation between like broad groups of trees where you'd be able to, or where other people might be able to apply the insights that you got from your project?
Yeah, so what we found with the Sentinel-2 satellite is what we get, the spectral information that we get from that is really just representing the canopy leaf structure. So I think it'd be very hard to use that same data to get species level identification or even broader groups, but you could potentially use like a higher resolution satellite or maybe hyperspectral data to get more precise classification into species or richness. But for Sentinel-2, it's really just the leaf structure that is influencing the signature and the absorbance of the light.
Other questions? Maybe I'll jump in with a question for Alex while people are thinking. I mean, what does your research say about kind of future climate changes, and can you say anything about how that might affect the particular areas that you're working in?
So there's two reconstructions I'm trying to do. I'm trying to reconstruct temperature in alpine areas, and then in the cedar forest, I'm trying to reconstruct moisture over the past 800 or so years. And I haven't gone to the actual modeling part, so I couldn't say what the results are for that. But we do have a very good sensitivity in both to temperature at our alpine sites and moisture in our cedar forests. And as for climate change and environmental change in general, these are both pretty sensitive ecosystems. So the alpine ecosystem, we are seeing that the trees are getting more dense, and there is some encroachment of bush species going from the forest into the alpine tundra, and that changes the dynamics there. And then for the cedar forests, most of the change that has been seen is related to forestry, because cedar forests, old growth cedar forests are actually quite rare now, whereas they used to be much more common in the landscape in Quebec. But because of forestry, they've pretty much all been clear cut, and they don't recover as well as other species. So there is an interest in understanding how this forest evolved over time. So by seeing the trees that have fallen into the lake, we could see if the ages change, if their growth rate changed over time, and then use that to inform just future forest management strategies and whether there should be changes made with regards to global warming as well.
Anyone else from the audience? One question for Olivier, just to be fair.
Yeah.
So you talked a little bit about how reforestation might actually affect the magnitude of wildfires, or the amount of forests that are burned. So what about the other direction? How does wildfire potentially affect the efficiency of restoration, or the ability to use land-based systems to absorb and store carbon?
Well, it's actually one of the questions of my comprehensive, close to that. So basically, it depends. With wildfire happening more frequently at higher latitude, the forests or reforestation project that we implement cannot recover fast enough if there's an increase in the frequency of wildfire years after years. So that can be a big impact because it's affecting the carbon cycle in the end. So the carbon cycle is not as fast as the wildfire frequency, for example, if it increases, which can lead to problem with the carbon storage, etc. Okay. Good.
Any last questions from the audience? Okay, we're going to move on to the next panel. So if everyone can just hang tight for a few minutes while we switch over, and if Mitchell, Breanna, Darren, Duane, Claire, and Sonali can come up and take a seat. Yeah, sorry. Mitch, Breanna. We need one more chair.
Yep, there's one just right back there. Don't worry about that. I will get you. I'm going to put that on you properly in the future. Yeah, please do. So don't worry about the mute button from here on out. We got you, okay? And I am just going to place it to make sure everything is there we go. Nice and jazzy. Perfect. All right, so we have Mitchell, Breanna, and then we have Duane. Great. And then Claire, then Sonali. Perfect. Just something to note, don't know if it was gone over with you guys, but that microphone is one directional, so please make sure you speak directly into the microphone. If you're someone who gestures, pick a hand. Pick a hand to not gesture. As you've seen, the slide will be visible up there. If you notice the slide is not yet visible, don't mess with the pointer or the clicker because you're not gonna see what's going on just yet. So just wait till the slide is visible and then go, and you're good to go. Beyond that, we know what's going on. No worries if you run into any tech troubles, just be like, hey, fourth space, what's going on? And we'll do our best to help you. Besides that, have a good presentation.
Okay. I think we're ready to go. Am I live? I think you can hear me? Okay, let's move on to our second panel. Thank you everyone for being here. So on this panel, we're going to go in the same order for the presentation, same format, 3 minutes each, followed by some time for questions. So please think of your questions as you're listening, and feel free to volunteer to bring them up. I do want to make sure everyone gets a question, so I do have some backups if need be. But I'm happy to cede this question space to you all if you have things you would like to ask. So we'll start with Mitchell Dickau, who is a PhD student at Concordia in my lab, as you will no doubt note shortly, in year 4 or 5 of the program, 4.5, something like that. Mitchell was in the first cohort of the LEADS program, so he's been here since the beginning, actually. Next, we will have Breanna, and you are in year 2 of your master's degree, and also year 2 of the program. So looking forward to hear what you have to say. Duane Noel joined the program last year, so is also in year 2, is a PhD student here at Concordia. Claire Burnel is a PhD student from the University of Montreal, working with Sarah Teitelbaum, also in year 2 of the program. And then we have finally Sonali Uppal, who is a PhD student from McGill, and also in year 2 of her program. Thank you all for joining us, and let's jump right in. Mitchell.
All right, so in my research, I use a climate model to investigate how the Earth system responds to emissions. And one of the questions I've been looking at in my research is, what are the consequences of first exceeding a temperature target and then returning to said temperature target? And so we refer to this phenomenon in the literature as temperature overshoot, or just simply as overshoot. So one of the ways we can investigate overshoot is by simulating a scenario in a model where temperature rises, reaches a threshold, let's say 1.5 degrees, and then remains relatively stable at this threshold. And this would be a non-overshoot scenario. And then we can simulate a second scenario where temperature rises, exceeds this threshold, and then returns to this threshold. And this would be the overshoot scenario. And by comparing these scenarios, we can investigate at some of the impacts of temperature overshoot. So in my research, this is supposed to be a GIF, so I don't know if it'll play, but I simulated 44 pairs of overshoot and non-overshoot scenarios in the UVic climate model. So one of the questions I looked at was how irreversible or reversible are the climate effects of temperature overshoot? And to answer this question, I needed to come up with some kind of framework to define reversibility. And so how I did that was for any variable aside from temperature, I would look at if whatever change occurred during the period of overshoot, if it was reversed by the time that temperature was reversed in the overshoot scenario. So let's say we're dealing with a variable like sea level rise. If the amount of change that occurred during the period of overshoot wasn't reversed at all, it would be 0% reversibility, which is here demonstrated by this red line. The orange line shows 50% reversibility, and the yellow line shows 100% reversibility. And so using this framework, I looked at all the different variables in the UVic climate model, and I found that, unsurprisingly, slow responding variables with lots of inertia show that they're not very reversible after overshoot. So here, this figure shows reversibility as a percentage, and we see that lots of ocean and permafrost variables are under 25% reversible. Now, a second question I had was, how does the magnitude and duration of overshoot relate to the climate effects of overshoot? And we can quantify the magnitude and duration of overshoot using something called degree years. And that's really just the integral of temperature between an overshoot and non-overshoot scenario, or just that space between the curve of temperature for the non-overshoot and overshoot. And interestingly, what we found in our simulations was that there's a linear relationship between the degree years of overshoot and lots of, and the amount of change that's irreversible after overshoot. And so this figure shows that relationship for thermostatic sea level rise, so the sea level rise from warming waters and them expanding as they warm. And interestingly, this relationship holds up for several variables in the UVic, and it's also independent of the peak temperature. So yeah, and here are some of the other variables, but I won't go into them. Thank you.
Great. Thank you, Mitchell. Moving on to Breanna. Maybe, I think that's from mine. Yeah, keep going forward, fourth space. Next slide. You can also use the little pointer thing, yeah. There we go.
Oh. Sorry, we're fighting each other.
There we go. Okay.
Okay. All right, so my focus is in fluvial geomorphology, or the forces and variables that work to shape rivers. And rivers are dynamic entities, and flooding can lead to erosion and deposition that in turn can promote lateral or vertical mobility of rivers. So a couple types of river mobility are bed incision, and this is vertical erosion of the river into its riverbed. There's also lateral migration, so that's the lateral movement of the river as it erodes its riverbanks. And this process will continue until a cutoff or an avulsion occurs, as the river will try to reach back to equilibrium. And so an avulsion is the abandonment of a river channel and the creation of a new one. And then lastly, there's channel widening, so that's when bank erosion leads to migration of the riverbanks and widening of the actual channel. And although these processes are natural and necessary to maintain integrity of river ecosystems, when communities or infrastructure are exposed to them, safety and integrity can be compromised. And historically, management methods have relied heavily on bank stabilization to maintain rivers in fixed positions. But these hard engineering approaches often fail when used in naturally dynamic meandering or wandering rivers. So these are rivers with many meanders or secondary channels and high sediment loads. And these also tend to be close to human settlements. So this becomes an increasing concern for governments as more frequent floods result from climate change. And as I said before, rivers will inevitably adjust towards their natural equilibrium despite all interventions. So in my picture here, I have one of the tributaries of one of my study sites on the Dickau River in the Chalifour region in Quebec. And this was after a flood last year. This tributary was stabilized and straightened in the 60s. And after the flood last year, you can see it very much returns back to its wandering and many channel state. And so that leads me to the objective of my research, which is to develop tools for assessing mobility of these dynamic river reaches and trying to see if we can predict these changes before they happen. So I'm focusing on two rivers in Quebec. One is the Dickau and its tributaries. And my focus here is mainly with the flood in 2023. And also the St. Anne River in Gaspésie, where there was a major avulsion in 2015. This avulsion was more on the business as usual, just kind of like a normal thing that eventually happens, which is different from the Dickau mobility, which was due to a large flood. So I'm using hydrogeomorphological variables and creating kind of a portrait of these rivers to see if I can use these to predict mobility before it happens, so it can be incorporated into restoration and river management practices.
All right, thank you, Breanna. Moving along, Duane. Yeah, I got it.
I pressed the, sorry.
If it's just one slide, you don't need to.
Okay, sounds good. So thank you very much. So I just want to say good afternoon, everybody. My name is Duane Noel, second year PhD student at Concordia University. So my project's titled The Impact of Atmospheric Conditions and Long-Term Climate Variability on River Mobility and Flood Mapping. So the goal of my project is to understand how the antecedent soil moisture conditions as well as the atmospheric conditions are different before and after a major flood that causes a lot of river mobility, as well as consider the changes in climate oscillations that play a big role in our climate. For instance, the El Niño summer oscillation, which it's a big climate pattern that affects precipitation and temperature across the world, as well as local patterns such as the Atlantic multi-decadal oscillation, the AMO, and the North Atlantic oscillation, the NAO, and how that affects flood magnitudes. And then lastly, a case study looking at the geomorphological changes in southern Quebec rivers. So just like Breanna, I'm also working on the Rivière du Gouffre as well as the St. Anne River. So the Rivière du Gouffre is in the Chalifour region, whereas the St. Anne River is in the Gaspésie region. So looking at how the changes in flood extent as well as the changes in flood depth change before and after a major flood event, in particular for the Gouffre, and the avulsion event for the St. Anne River. And then lastly, my experience in Leeds has been really good. Most notably, I enjoyed the Leeds class that I took this summer and learning about Google Earth Engine. That was one of the most relevant classes that I thought, especially that lecture about how Google Earth Engine has many different applications, and primarily in my case, how it can be used for flood modeling. So I really enjoyed it, and I hope that the new students also have an opportunity to take the class. Thank you.
Great, thanks. Nice pitch for the summer school. So yeah, Claire, go ahead.
Yep, so my name is Claire. I'm a second year PhD student at the University of Montreal in the sociology department. I don't have a PowerPoint.
Okay.
And my work focuses on three things. That's biodiversity, conservation policies, and the kind of the interface between science and policy. And I work on the quantification of nature, and specifically when that is made for conservation policies. And that is usually, so that's basically when
I'm interested in looking at how scientists take vast amounts of biodiversity data and then transforming that into something that's useful and relevant for policymakers and for conservation policies. And that usually is done through the production of biodiversity indicators. So those are very common tools now that are basically these vast amounts of data are simplified, sometimes to the extreme, into very simple numbers. So that would be, for example, we've lost 30% of birds in the last 30 years. That's an indicator. And for my PhD project, I'm interested in seeing how these indicators are being produced currently in Quebec with all of the specificities that involves. And I find indicators fascinating because there's a lot of controversy around them, but at the same time, they're seen as a useful and even essential tool for policymaking. So some experts, on the one hand, think that they oversimplify the ecosystem and biodiversity processes, and so that they're not adequately describing those processes. And that would mean that the policies that are based on these indicators are not quite adequate either. But at the same time, we do need tools to simplify these processes. Otherwise, how can we make policies that are relevant for conserving them? And so that means, I think, that it's essential to understand basically what goes into producing these indicators. What is taken into account? What is left behind? Who gets to decide of this? What actors are heard during these debates and what actors are left behind as well? So I'm still very much building my research project. I'm still trying to figure out what exactly I'm interested in studying, but basically what I want to do is understanding all of the socio-political processes that underpin the production of indicators in Quebec. So yeah, and I'll probably be looking at two themes specifically, and that is protected areas and species at risk, and kind of looking at the indicators revolving around these themes. And regarding LEADS, I'm in my second year now, I've just begun. I'm very grateful to be a part of LEADS because, obviously they're partly funding my research, which is very important to me, so thank you for that. But also I've met many very inspiring people who work on very inspiring and important projects, such as the ones we've seen. And I haven't had the chance yet to take part in the internship or the summer school, which I'll be doing this year, so I'm really looking forward to that, to gain as much skill as I can to go forward with my research. Thank you.
Great, thank you, Claire. So finally we have Sonali Uppal, so please go ahead.
So hi everyone, I am Sonali and I am a PhD student at Mikaela in business school, but I'm focusing on social enterprises. So so just imagine an organization which is run by unpaid employees for an extended period of time, like more than 30 years. So that is actually the research I'm focusing on, and it brings me to my research question of how an organization which is run entirely by volunteers has survived for more than 3 decades, and it's a social business enterprise, and it's a business. So for that, I am looking at an organization in Ontario. It's a very small store which sells fair trade products, and it's been run entirely by volunteers, volunteer manager, volunteer employees, and volunteers are central for them, and they also boast about it. And I'm trying to understand that how they are able to survive for this long. What is keeping them motivated to come back and work as a volunteer for these volunteers have been working there for 10, 12 years. And so we so for this study, I also started working as a volunteer at the store. I visit there, I work as a volunteer, collect data, interview them, and understand what's happening. And we have come to a conclusion. These are just preliminary findings, and we are probably gonna look at a different lens now. But for now, we have come to the conclusion that these volunteers are kind of playing a dual role. They are an important resource in a region where the resources are not available, and at the same time they are enacting as bringing in more resources. So they are enacting as an agents of resources. So that's the dual role they are playing. But again, this is preliminary, and we are going to try to look at it from a very different lens now as a next step. So yeah, thank you.
Great. So as before, if you have a question, please put up your hand and the microphone will be delivered to you.
Thanks, you guys. I have a question for both Breanna and Duane. Since there's some overlap and you might both be able to give some insight. I guess you both mentioned that the outcome of these river mobility events, like that there might be, there's natural cycles that may play a role in certain ecosystems, and Duane, you mentioned the impacts on humidity and things, or the local environment, and I'm curious to know if there's any sort of contradicting priorities when it comes to mitigating these events or predicting them. If are there any sort of contrasting impacts on ecosystems and communities that could be contradictory, or just is there anything that needs to be taken into account there? Sorry if the question isn't clear.
I think yes, definitely, between trying to keep people who do live near these rivers in their homes, but also make sure that they're not in a position where they're going to get flooded out. So I think that if our work shows that this part of the river has a high chance of widening or an avulsion occurring, but people live there, or on the tributary that I had, there's a campsite right there. How do you manage that priority of not trying to dislocate people, but also not trying to put people's lives in danger? So I think that's a really big one that I don't know how to answer, but that'd be my biggest. Anything?
Yeah, I think I agree as well. It's a challenge to balance pretty much keeping people safe, but also not displacing the homes that've been there, and how there's been. It's clear that there's been settlements near, especially the Dickau, because that's where we're seeing most of the big changes. So I think both of our projects will have that challenge to explain what are the potential solutions for that, and how do we convey this information to the government to make better decisions in terms of flood mapping. So then the people living near the rivers could remain safe, but also be aware that there is that risk of flooding. So, yes.
So just to expand a little bit, so you mentioned the St. Anne, the river near St. Anne. I think you said there's only minor changes in the mobility of the river. Is there a situation where you could predict a river mobility event and be like, great, this is going to add some heterogeneity to the ecosystem and promote certain ecosystem processes if it's not too far from, or if it's not too close to a settlement?
I think that's one.
So I think, I'm not sure if I'm understanding your question right. Are you asking if exclude, if there's no people living there, if we can predict how the mobility will affect the environment? Is that this?
Because I understand your research is more focused on keep the safety of people, and is this sort of modeling also used for people who are looking at ecosystem processes and change in ecosystems?
I feel like it definitely can be. For the instance of the St. Anne, where this avulsion occurred, there was nobody living there. And from my preliminary results, it seems like we could have maybe predicted that happening. So then that changes where the river, where the actual main channel is, now where the floodplain is, and now there's a scar. So I think that changes what is happening there. And the St. Anne is important for salmon reasons. So if for people trying to manage it for fishing or whatever, I think that it can definitely be helpful for them as well, because it'll be part of the general flood maps, right? So I think so.
Great, thank you for
Is that
navigating my question.
I have a question for Breanna and Duane again. I'm not sure if I understood what you are doing can help how the river has moved or how the river will move.
Fatima, can you repeat your question again, please?
I'm not sure if I understood what you are doing is like how the river what was moved through the past few years or how it will move. Like, are you going to model and like say, okay, so river will change its bed to this place and like it will affect, now it's affecting this area and in future is going to affect like other areas. Is that part of your research?
So in my research in particular, at least that part of it, it's yes, because the Dugouf and St. Anna is a particular case. Usually we tend not to have like a before and after, but in this case we actually do have before and after these geomorphic changes. So for that chapter of my PhD thesis, yes, I'm using the baseline, the before. So let's say we look at the Dugouf, the 2013 will be my baseline of geomorphic changes, and then 2023 after the major flood, that I'm comparing how does the flood extent change and what's the consequence on the flood maps. So do we need our flood maps could they remain the same? Do we need to change it? Do we need to consider the river mobility of the main channel? Do we need to consider the river mobility that's going on in the tributaries? So in my particular case, yes, there's a reason why we're doing the compare and contrast, and that's because, especially for the Dugouf, there's lots of evidence showing that there's been river migration and changes in the channel width. So, and maybe.
Yeah, I'll just add for mine too. I'm also looking at before and after, but also some of the tools that I use is reconstructing the migration over a large period of time. So I'm using like aerial imagery and tracing the river and seeing how it moved from the 60s ish. So looking at what happened, and then based on what the history of these rivers are and the current data that we have, can we predict future changes? So it's a bit of both.
Yeah, another question in the back.
Hi, question for Sonali and maybe Claire. Sonali, really cool project. I'm interested to talk to you more. And I wonder, personally, I'm always interested in what is the economic impact of volunteer activities. So are we bringing foot traffic downtown to that area that might be spending money? Or are we avoiding, I don't know, health consequences so that there's an economic benefit to a healthcare system because of whatever volunteer opportunity? So I'm just wondering if you've ever considered economic indicators in your study, and then to Claire, is economic indicators a good way to go if we're looking to sort of understand more of the social impacts of X project? It could be volunteer, it could be nature, it could be biodiversity, whatever. So just linking the two there, both are really interesting projects. Thanks.
Thank you. So since I'm looking at, so my unit of analysis is volunteers and that particular social enterprise for now. And we did consider looking at the economic indicators, and especially there are papers which talk about the opportunity cost of the time of these volunteers. So there is some research on it, but then they are talking about the opportunity cost of time of these volunteers in corporates, not the social businesses. So we might look into it. We have this as an indicator with us. But for now, we are trying to understand the meaning of work for these volunteers. What is how do they value their time? Time in terms of money, or time in terms of service, or creating your own identity, or other factors. So, but yeah, thank you for the suggestion.
As for me, I I'm not exactly choosing the indicators that I'm going to be working on. So my case study is 2 programs that are currently under development in Quebec. One is like a scientific program, which is the kind of the idea is to monitor the state of biodiversity in Quebec, and the other one is a very like political one that is derived from the new global framework for biodiversity that was just voted. And so they're going to be taking global indicators and then adapting them to Quebec, which is really interesting to look at. But it is true that there are a lot of different indicators in that framework. For example, there are social indicators, like kind of hard scientific indicators on the state of biodiversity. There are probably some economic indicators as well. So I'm still looking at that, so I can't really answer for now, but probably that, yes, that is something that is definitely taken into account, especially in policies, because obviously like economic impacts are always taken into account. So I'll probably be looking at that in the future, yeah. Thank you.
Maybe just a quick follow-up on that point. Yeah, I mean, are you thinking of like other than biodiversity metrics, like what are the co-benefits that you could also tie to that metric? Whether, so yeah, economics could be one. You could also think about like climate or carbon or water as like other kind of related indicators that, I mean, if you can like kind of combine those together into one unified metric, that would be a really interesting outcome, I think. Anyway, sorry, Alex, you had a question.
Yeah, it's a question for Mitch. That figure you had with the reversibility of certain impacts from climate change, what were some of the ones that were more reversible? Because you talked about the few that weren't, like permafrost.
Yeah, so a lot of the changes that co-vary with temperature quite closely are reversible, because based off the framework that I'm using, temperature is reversed. So all the impacts that are very closely tied to temperature are quite easily reversed. So sea ice extent, for instance, is like quite easily reversed in the UVic model.
So then why is something like permafrost, which I would imagine is quite tied to temperature as well, why is that less reversible?
Because the permafrost formation happened at a time when Earth was much cooler, so it melts, but then you're not actually bringing it back down to the temperature that it was formed at, right? Or with a lot of the ocean variables, what's happened is, say, for ocean warming, it's not very reversible because you have water on the surface warming, but then some of that water is downwelled through ocean circulation. And then once temperature is reversed, it's no longer freely exchanging heat with the atmosphere, so it's essentially locked in.
Any other questions? Maybe I'll ask a quick follow-up question to Mitchell. I mean, yeah, so you talk about temperature being 100% reversible kind of by design, but maybe you could talk about what that actually looks like what type of scenarios this, why are we interested in overshoot scenarios
right.
in the context of this like 1.5 or similar climate targets?
Right, so in the scenario literature for especially 1.5 degree scenarios, a lot of the economic models that come up with the emissions pathways that we might have include a lot of carbon dioxide removal. And so by removing carbon dioxide from the atmosphere, we can theoretically bring temperatures down. A lot of this is contested as not very realistic, that we won't be able to actually have carbon dioxide removal on such large scale. But then the other reason I feel like it's an interesting question is because maybe even if we don't have carbon dioxide removal, if we reach net zero emissions, that will also mean that we're probably mitigating a lot of the non-CO2 emissions that are co-emitted along CO2 through the burning of fossil fuels. So a lot of our anthropogenic methane emissions would be reduced inherently if we reach net zero CO2. And when you reduce the rate of non-CO2 emissions, you have decreasing temperature. So we could, it seems quite unlikely that we would reach net zero CO2 and just completely remain stable, but rather we'll probably reach a temperature and then decrease slightly afterwards.
Okay, any last questions? Okay, So thank you panel. So we'll move on to our third panel. So if Meagan, Michael, Ariane, and Zare can come up. So I'll just quickly introduce the panel. So we have 4 speakers this time. We'll start with Meagan Oxley, who is a master's student here at Concordia in her 2nd year, followed by Michael Ekwe, who is a PhD student at Concordia, also 2nd year. Ariane Peroni, who is in her 2nd year of the Leeds program, but 1st year of a PhD, having, I believe, just transferred from the master's program. And then finally Zare, who is a PhD student at Université de Montréal. I think you're in the 3rd year of your program. So yes, thank you everyone for coming and for listening. And Meagan, I think we can get started with you as soon as we bring your slide up.
Okay, I need to stand up so that I can be able to point. That's okay if I can just have the camera follow me. Okay.
You can use the pointer.
Okay, I feel like it's just easier if I can do that.
Does that work with the camera setup?
Is that good? Okay, awesome. Thank you so much. Okay, hi, my name is Meagan Oxley. I focus on fossil fuel lobbying, linguistics, and climate change and energy policy. So we know that the fossil fuel industry has boatloads of money and time to spend on lobbying against climate change issues with the Canadian government. And this huge portion of lobbying power is an issue when trying to create actually effective climate change policy that focuses on degrowth rather than promoting endless profit and growth. So I decided to build my thesis as a linguistic analysis of the words used in the fossil fuel industry's lobbying and PR documents in order to research how their disproportionate power impacts the effectiveness of climate policy. Then I cross-referenced their language patterns with 2 recent Canadian energy policy documents. By doing this, I'll be able to determine if their lobbying is actually being integrated into our policies. See, the government never actually makes official statements on whether lobbying persuades policy or not, but I'll be essentially reverse engineering that and finding out for myself. Most of this section of my research I did quantitatively through text mining and R. But I also have a qualitative aspect of my research where I categorize the fossil fuel industry's specific arguments, and I'm also creating a list of their most strategic terms that they use. And an interesting pattern that I've noticed is that the language that the fossil fuel sector uses is heavily greenwashed to maintain this positive appearance while pushing for a destructive pro-growth climate policy. I've got some examples of these sneaky words that they've been using on the screen, along with their frequency across the 18 documents that I've been analyzing. Like, for example, the fossil fuel sector is obsessed with promoting carbon capture as the cure for climate change, but not just regular carbon capture. This is carbon capture utilization and storage, which is where they take the carbon, inject it into the ground, and then use that to help pump out more oil, which is a really fun thing that they do. But at least they're better than dirty coal, which is the real culprit of climate change, not the innocent, clean oil and gas sector. But we need to be easy on them. The energy policy we have now is very ambitious, and maybe these policy nerds in Parliament were just getting a little ahead of themselves. We need to make sure that the government collaborates with the oil and gas sector so that regulations are actually achievable for them without sacrificing growth, of course. These are frequent arguments that I've found from across the fossil fuel industry's documents, and the frequency of these terms are statistically significant. For comparison, you can see that across the 18 documents, the word normal, a pretty normal word, only shows up 9 times. But you can see that words like affordable appears 142 times, global appears 615 times, and carbon capture and its abbreviations appeared 1,075 times. So both quantitatively and qualitatively, the patterns have been emerging strongly, and I'm really excited to be soon taking the next step to compare it with the Canadian energy policy documents. Thank you.
Great, thank you, Meagan. So, Michael, you can go ahead.
Hi, everybody. My name is Michael Ekwe. I'm a PhD candidate at Concordia. My supervisor is Dr. Angela Cross. I study corn and soybean leaf area index and biomass from multi-sensor data. We all know that crop production is sensitive to extreme weather events such as flooding and drought. So farmers need to rapidly monitor their crops to avert losses due to climate change. So one way to monitor these crops is to monitor yield indicators such as leaf area index and biomass. Basically, we measure crop leaf area index using proximal sensing technology, such as pocket LAI application. And for biomass, we use destructive sampling approach. And to estimate these parameters, we need satellite-derived features from drone and satellite images. Then we apply statistical and machine learning models to predict these parameters. My study area is focused on 2 provinces of Canada. I have SmartVest project site located in Manitoba, and for Ontario, I have Eastern Ontario, Winchester, and Webb's project sites. So for the Winchester and Webb's projects, we'll be looking at can the models for estimating corn and soybean leaf area index and biomass be transferred between different spatial scales. So here we are developing models at a very fine scale, say 1 meter, and try to extrapolate these models to predict these parameters at 5 meters and 10 meters respectively. So during the summer of this year, we conducted field campaigns at 2 sites, Winchester and Webb's, all located at Ontario. So these are some of the interesting results that we got from our data. So for average chlorophyll content, corn recorded the greatest value. For average canopy cover, soybean recorded the greatest value, and for biomass, corn recorded the highest value. So for my second research question, I'll be looking at can combine sensor data, optical radar thermal with environmental and microtopography parameters improve the estimation of corn and soybean leaf area index and biomass. So here we'll be introducing thermal remote sensing data, which hasn't been explored before in the estimation of these parameters. And we will also incorporate other ancillary data sets such as environmental and microtopography parameters and see how this could improve the estimation of these important crop parameters. And lastly, for Eastern Ontario and SmartVest project, we'll be developing models and we'll try to transfer these models to different crop types, different geographic locations, and different time scales. So the take-home message for farmers to effectively monitor crops in a changing climate. Crops leaf area index and biomass, which are yield indicators, need to be accurately estimated. Thank you so much.
Great, thank you. Ariane?
So, bonjour à tous et à tous. Je vais faire cette présentation en français parce que je parle mieux français. Mais les slides sont en anglais pour que ce soit vraiment plus inclusif. Donc voilà, donc je suis étudiante en doctorat en première année sous la direction du docteur Sarah Turner. Plus précisément, je fais partie du PAIS Lab, qui est un laboratoire de primatologie et d'études environnementales interdisciplinaires. Je suis quand même assez fière d'en faire partie parce que je suis vraiment contente que ça regroupe des étudiants qui sont vraiment passionnés en fait par les réponses et les adaptations des changements globaux dus aux activités humaines. Toutefois, ça reste un laboratoire de primatologie, donc on étudie les primates non humains et j'échappe pas à cette généralité. Donc, pour l'instant, c'est le first draft de ma thèse. Donc, c'est sur l'influence de l'environnement sur les opportunités de choix, en fait, et les comportements dirigés. Donc, les comportements dirigés, c'est tout ce qui est se gratter, se nettoyer, qui, lorsqu'ils sont trop récurrents et trop répétitifs, indiquent un mal-être, un signe de stress chez les singes. Je vais étudier ça dans des populations captive et en liberté. C'est en fait une thèse un peu comparative. Donc c'est mes objectifs globaux. Donc c'est étudier comment les variations environnementales vont impacter en fait les prises de décision et le nombre de prises de décision chez les macaques japonais en liberté et en captivité. Ensuite, le deuxième objectif, il est en pourparlers avec une institution, donc je ne peux pas en dire plus pour l'instant. Puis en fait, le troisième chapitre, c'est sur la communication scientifique. Puis c'est là où le lead intervient, si je puis dire. En effet, c'est suite au workshop de l'année dernière où je me suis assez rendu compte à quel point c'était important de participer en communication scientifique, parce qu'en tant que chercheur et primatologue, c'est notre devoir aussi d'informer le public, tout ça, tout ça. Donc, qu'est-ce que le lead m'a apporté? Déjà de choisir ce troisième chapitre. Puis je trouve que c'est vraiment... il m'a aussi fait comprendre l'importance de la collaboration scientifique, à quel point c'est important dans la recherche. Puis je pense que dans une ère où on est tous un peu dépassés parfois par la technologie et par les changements climatiques, puis on peut vite se sentir un petit peu subjugué par tout ça, si je puis dire. Je trouve que c'est un programme qui remet un peu les pieds sur terre, puis qui aide en fait à comprendre les challenges de la technologie, notamment de l'intelligence artificielle, et l'importance de nous introduire dans nos recherches l'atténuation des changements climatiques. Voilà. Et du coup, voilà.
Great. Merci beaucoup, Ariane. So our last speaker of this panel and of this part of the event, Sarah, please go ahead.
Okay, thank you. I have some slides. Okay. My name is Ghaboulian Zare. I'm a member of GEGAT, LEADS, and some other research group. And I'm a PhD candidate at the University of Montreal in the computer science and operational research. Actually, my project is connecting OR techniques, operational research technique, with the real-world energy system. More specifically, I concentrate on the energy system of Montreal for now, and I want to integrate hydrogen technologies to reach deep decarbonization. Okay, first of all, I go through the hydrogen strategy map for the Quebec. As you can see here, different industries like green chemistry and steels are among the highest priority, and also different transportation sector, which are hard to abate by other commodities, like, for example, maritime, aviation, trucking, are among the highest priority for reaching neutrality using hydrogen. So in my modeling and in my project, I concentrate on these technologies, and at the next step, I go through the modeling. Now I know what technology I want to concentrate more, and I go through the ETEM model. ETEM stands for Energy Technology Environmental Model. It's a bottom-up regional model that you can add different sector, different commodity, different technology into the model based on the research question and based on the need of the scope. For now, the concentration is on Montreal, and we included 5 different regions: Montreal, Laval, Longueuil, North, and South Montreal. And we have about more than 150 different technologies, about 75 different commodities. And for now, the time period is from 2015 to 2050, and we have 96 different time slices. After that, like other energy systems, first of all, I should go through the defining the sectors. For example, here I define different supply and demand sectors. For example, for hydrogen, we have lots of different primary energies like fossil fuels, and then we produce hydrogen, and then using different conversion, we can produce different secondary energy like electricity, for example, liquefied hydrogen. And then using these defined primary and secondary sources of energy, we can use these sources in different technology and on the demand sector. For example, we can use electricity on transportation, and then this transportation can be used to define a part of useful demand. In fact, I go through each of these technology and then develop the databases. If I want to go in more detail, To define those technologies, first of all, we define different technology for each of them and lots of different commodities. And for each of them, we should define technological databases, for example, different efficiency, different cost for the databases. And after defining this reference energy system, we are defining different databases, update and calibrate the databases. For example, here we have the production of hydrogen, then we go through distribution and delivery, and then after that, go through the utilization. I have some initial results, but because of the time, I passed through them and skip them. I want to just mention that in most sectors like industrial sector and hard to abate sector like transportation, the hydrogen play an important role to reaching neutrality. That's it, thank you.
All right, thank you everyone. So again, if you have a question, we'll start in the front here. Mitchell.
I have a question for Sarah. So hydrogen, my understanding is it takes a lot of energy to produce it. So if you're producing hydrogen with fossil energy, it's obviously not carbon neutral. But in Montreal, do you know like how hydrogen is produced predominantly? What kind of energy is being used?
Do you hear me?
Yeah.
For now, based on my last conversation with the industrial sector, we have just decentralized the SMR, produce of hydrogen using decentralized SMR. More specifically on Sanko, we have hydrogen production, which is used at the refinery and at the same place for now. But in the long term, and by 2050, we have Montreal has the plan to produce hydrogen using green sources, like electrolyzers, and use it more specifically, as I mentioned, in green chemistry. We don't have it for now, but it's in the plan. And also refinery, and also for maritime. These are based on my last conversation with the industrial sectors, as I know. But for now, we have just SMR production of hydrogen.
I'm just curious, so, because I believe Suncor, because I've been researching this, they really push for using their natural gas for hydrogen. So I'm curious as well for like how that outlook looks for decarbonizing the grid.
Thank you for your questions. Actually, for now, it's not, they use natural gas, and they don't use CCS, as you mentioned, CCUS. But as I know, based on their plan, they have the plan to have green hydrogen production by 2030. I'm not sure is it acceptable, is it reliable way to reach neutrality by these sectors? Because, for example, when I was reviewing on my literature review, when I was looking to different pathways, for example, we had for CMM, yes, Greater Montreal region, we have the plan to reach, for example, 37.5% reduction by 2030. But for now, there isn't no reduction within 10 years. I'm not sure is it reachable or not, but they have the plan to reach it using CCUS.
All right. Other questions from the audience?
This is a question about the language and the reports. What do you expect to see a big difference between was it the IPCC report that the graph you were showing was on?
The report that I showed was I text mined 18 different documents across several different high lobbying fossil fuel companies, and they're like, sometimes they're like the Canadian Association of Petroleum Producers, so they're like organizations. And that showed like, those were some of the top big words, not all of them, but I picked a few of them to show. So that's just the information on that.
And then you said you're looking forward to comparing it to the Canadian
policy. There's two policies I'm looking at, the clean fuel regulations and the clean electricity regulations.
And so are you expecting to see a similar like a lobbying effect on the linguistics for the Canadian, those reports?
Yeah, I might change. I did get some feedback that like regulations might not be the best place to look because sometimes they can be a bit more technical in language, whereas the lobbying things are a lot less technical. In language, they're a bit more goals-based, but there is a lot of policies that are more goals-based from Canada, so I can easily change that up before I go into it. But I do anticipate that there will be some transfer over, especially I was doing research before in energy policy, and I noticed that like there's very similar patterns, and this was across the world, there's very similar patterns in how people write policies, and so that's what got me interested in the linguistics of it and seeing if things would carry over. And so I want to see like how much does carbon capture actually transfer over, how much do, like the words like cogeneration is another one that transfers over. I'm really interested to see, and I think I'll probably see this as like lower carbon, which sounds like a pretty positive thing, but it's actually very ill-defined term that the fossil fuel companies use a lot because it is ill-defined, and anytime that is defined, it's usually just 10% lower than like traditional oil and gas, and that's over the entire value chain. So that can mean like if you've got an electric truck that brings the oil somewhere, that can like maybe reduce the load to make it like clean oil and gas, you know? So, and like lower carbon oil and gas. So I'm interested to see which of these terms, and when I was looking over some of these policies before, I did notice that there was patterns in themselves that were occurring. So I do believe that there will be probably some transfer over. And they do lobby them like 6 times a day. It's one of the biggest lobbying sectors, so.
Are you doing any analysis over time to see if the linguistics have changed?
Oh, yeah, I'm considering, if time allows for myself to do it, I would love to do, especially with the clean electricity regulations, because they're actually like, it's a very recent thing, and they have, the Canada Gazette allows actually to see like when Suncor posts some of their lobbying documents, and other companies as well. And so you can see like first editions and different editions and how it's changed over time. So you can see how the language actually changes, and depending on like when they've received some of these lobbying documents. So that might be like even more evidence towards it.
Great, I think, was there another question? Other questions from the audience?
My question is for Meagan again. So I was curious, like there's something that you could do that is topic modeling to see like how terms are associated with each other, like tend to co-occur. So I guess what I'm wondering, like you could do it, but what I'm wondering is based on those documents that you read, do you see what are like the big general topics that this different lobbying documents have in common? Like if you see like different words together, what are like the big topics, the big themes that emerge from those documents?
Yeah, I tried topic modeling at first, but I found it fairly limited because like the topic itself was climate change policy, and I found that it wasn't able to get enough nuance on the topics. It was kind of just like, yeah, this is climate change stuff they're talking about. This one, like maybe it might be like now they're talking about water or biodiversity, but it wouldn't be able to get enough of that nuance I was looking at into the categorization of topics. So that's why I put it more towards like word frequencies and bigram and trigrams and stuff like that. And then I was like, okay, once I have that quantitative, I'll really go in with the qualitative and like use my human brain to kind of go through and determine what are these topics that are coming up, which takes a little bit more effort, but I just found that the computer wasn't able to determine the topics enough, because that was my hope at first, was to do like latent semantic analysis.
Yeah.
Sorry, just to add to the last comment. So if the topic modeling is not working well, wonder if you've tried looking into large language models, for example. So because I think if the topic model is not working, it depends on, for example, the lematizer you're using, or the way you break the words back into their base form. So in that way, it will like divide them into just like normal like sentences. So you probably want to look into large language models and passing all of those documents technically divide them into better lemma, and you should be able to figure out the topics and even the sentence if you want.
Okay, thank you. I'll talk to you about that more.
Maybe I'll jump in with a question for Ariane. I'll ask in English, but feel free to answer in French. I was wondering if you could talk a bit about why it's important to understand animal decision making, and what does that tell us about how animals might respond to environmental change.
Okay, so I will try to respond.
In English, in natural environment, the monkey has the possibility to choose a lot of things like foraging, what they eat, how they interact with others. There is a lot of vigilance, behaviors of vigilance to be sure that they will not die. And in captivity, there is no vigilance, for example. There is less opportunities, and the risk is, in the long term, some natural behaviors can be lost or altered, and it can lead to a genetic isolation. It can lead to compromise some reintroduction programs, some reproduction programs. So I think it's very important to investigate how captivity compared to the natural environment impacts this decision making and the diversity and the number of decisions available.
Right.
And it can increase also the stress of the animals, which is bad for their health and everything.
Right.
Thank you.
Maybe I'll just end with okay, yeah, another question from the audience.
My question is about the remote sensing of crops. I'm curious to know if in the future, so you have biomass and leaf area index. I'm curious to know if in the future you'd like to expand your sensing to have more variables, or if those two give enough information to assess how yields are affected by floods or what have you.
Yeah, thank you for the comments. In the future, I'm going to look at other yield indicators, such as chlorophyll. In fact, for our Winchester and Webb's field campaign, we also measure the chlorophyll content. Okay, so I'm going to also be working towards that, but yeah, I'm going to expand the yield indicators to include more variables in the future. Thank you.
Sorry, just to pick it on that, you said in your presentation that you'll be looking at how the model changes by scale. So I wonder if you've looked into that, and do you see the same pattern when you compare 1 by 1 or 5 by 5, or it's still a work in progress?
Yeah, it's still a work in progress, but the idea is I will have to still make reference to our field campaign. So what we did was to measure leaf area index, biomass, and chlorophyll content at 3 different spatial resolutions: 1 meter by 1 meter plots, 5 meter by 5 meter plot, and a 10 meter by 10 meter plot. So we also, I also flew a drone to capture the spectral information of the crops. And so what we're going to do is to develop models based on 1 meter by 1 meter, which is the finest scale. Then we have to extrapolate this model to see if we can estimate these parameters at more coarse resolutions, such as 5 meter by 5 meter and 10 meter by 10 meter scales. Yeah.
All right. Well, thank you again to our final panel. So, Doug, I don't know if you want to close the Zoom meeting at
I
this point?
will. I'll just say a quick thank you to everyone, of course, for the presentations and also the questions. Fantastic. It's just great to hear the projects. Also, just for everyone joining us on Zoom, we're going to close up the live stream now. Just a reminder, this remains available on our YouTube channel if you'd like to revisit it or share it there. And the rest of you, stick around. Okay, great afternoon, everyone. Bye.